So in this video, let's start off working on our project 2, which is the 2D dodge game. And let's start with the player controller as usual, and then later on we can move on to making the obstacles, adding some difficulty in there, maybe add some sounds as well. But to start, let's just start by working on our character controller. Just like anything else, the best way to start with, working on a new project is to just kind of set things up, kind of get us the space that we're going to be working in. So the first thing I'm going to do is download some 2D sprites. There's this website on your Blackboard under resources called Kini.nl. I believe the person's name is Kini. And they have a ton of free assets for us to use. If we just go to their website, assets, and there's these filters right under the search bar. We just click 2D. And that brings us almost 9 pages worth of 2D stuff. I haven't gone through everything, so I'm pretty sure not all these packs are usable. Like some of these are mini maps or, top-down kind of things. Could use them, but I'm pretty sure most of them aren't usable. But I'm hoping there's enough usable stuff here. If you don't find anything you like, on this website, you could just search 2D game assets free. And 2D game assets, I feel like, are a little more readily available than 3D game assets. So you should be able to find a bunch of stuff there that are free and that we can use. So I downloaded this first pack, new platformer pack. You just hit the download button, and then you can continue without donating. That will download a zip file, which is what I have open here. And we want to drag the sounds, the sprites, and the sprite sheets over. So you can just shift select all of them and then drag them into our project folder. I already have them in here, so I'm not going to drag them again, but that is what we would do. We would just click and we would drag them over here. So once we have them all in here, I'm going to be using the same project as I did for the rollerball, but you guys don't have to. Next thing, let's make a level for this. So I hit Control N, make a new level. I'm just going to save it under scenes, and I'll call this 2D dodge game. And let's just kind of set up this stage for, for it to work for us. So normally our Unity would be in this 3D mode, right? There is a little button up here on this gray toolbar that says 2D. You could press that button and it takes us into a 2D mode. Alternatively, you could just hit the 2 key on your keyboard, as in like 2D, to turn it 2D. The other thing we need to do is currently our main camera is perspective. Perspective is when we see things in 3D. So we want to drop that perspective projection down and change it to orthography. You can see that also changes my camera to just a rectangle rather than, a projection, like a perspective projection. It changes it into a little rectangle, which is perfect for 2D games. There's no sense of depth. Next, let's talk about working with sprites. So sprites are game objects, just like any other game object. If I was just to use this directional lights, sprites just use a component called sprite renderer. So we added in 2 types of sprites here. We added sprites and sprite sheets. So I'm just going to work with both of them. You can do all of this with just sprites. I just want to show us, that we can work with both of these. So if we just open the sprites, we can see it has backgrounds, characters, enemies, tiles, just a bunch of stuff we could use. If I look at the backgrounds, go to default, you can see that these backgrounds are all one individual picture, right? This preview, this is one background. Each file is one background. If instead I go to the sprite sheets and we look at this sprite sheet that's the background, you can see it's all of the backgrounds put together side by side. There's many uses for this. And if we have a lot of pictures, that means we're going to be loading a lot of individual files into our memory when we play a game, if you're going to be using a lot of sprites. If we pack them into one file, then we're kind of maximizing, the the data in that file, and we're only loading one file into our memory, and we're kind of reading different parts of it. So sprite sheets kind of help us save on resources. They make things more performant, and it's a big reason we use them in 2D games. Often you'll find a character is a sprite sheet, as in all of the frames for that character exist on a sheet, And our animation is just going through, each kind of pose on the sprite sheet. And this helps us save, if our character has a ton of frames, rather than having a ton of different files, we can do it all on one file. We just have each frame, kind of placed next to each other. So I'm going to use the sprite sheet to kind of place the background. When we click on any kind of image, so for example, this background, its texture type is default. The default texture type is what we usually use in 3D materials. When we put in a color map or a roughness map, that texture type is usually default. These are sprites. So we want to click this default and change it to a sprite. It says 2D and UI. We want to change it to that. Change it and then hit apply. Next, you can see under the generate physics shape, we have something that says install 2D sprite package. So that is another, package that Unity just doesn't have by default. It's one of their own, but we just have to install it. So just click that button. It's going to just get it from the package manager and install it into our project. And the sprite editor should open up by default. If it doesn't, the install button will be replaced with open sprite editor. We just want to click that. Now here we could click and draw boxes that kind of represent our shapes, right? Or if we click this slice button and hit slice, it should do that automatically for us. In this case, it didn't slice correctly because there was not enough gap between the sprite sheet, so it did not it didn't slice correctly, which is why it gave us this one large kind of rectangle. Usually, if our sprites are they have a good amount of gap, even 1 pixel, it should be able to cut it up properly. But instead of doing this automatic type slice, I can change that to grid by cell size. Like I know what I could do is drop down slice. Instead of automatic, use either grid by cell size or cell count. So for example, cell size, you can change the X and the Y pixel size. I know that each background is 512 pixels, so I put that there. You can see the slices are perfect. Or I can change by cell count, where we know that there's 4 in a row, 4 in a column. Change it to 4 by 4. We can see that the sprites are perfectly sliced. So hit slice. And now if I click around, I can see each individual square representing a slice of the sprite. I don't need these last two because they're empty. So we're going to hit apply. And now if we look back at the sprite sheet, there's a little arrow that kind of goes to the side. If we click that, it opens up every individual sprite in the sprite sheet because we sliced it up. From here, I can click and drag any of them onto my scene, and you will see it is just a game object with a sprite renderer. It still has a transform, but it's a game object with a sprite renderer. I'm going to place this in the middle of the screen, which is going to be 0 on the X and 1 on the Y. And the reason it's 1 on the Y, by the way, is just because the main camera is also 1 on the Y. So this is also 1 on the Y. If you want to make the main camera 0 and this also 0, that's fine. I'm going to rename this to background. The other thing I want is a character. So there is a sprite sheet for a bunch of characters. You could do the same slicing thing here. It's perfectly fine. Or I'm just going to do the simpler one now, which is they already have all the sprites separately. I'm only going to be using a few sprites, so it's fine. Just going to open up the sprites folder, characters, default, and there's a bunch of characters here. I'm just going to pick this one of these purple guys. Remember, again, when you click it, texture type is going to be default. We want to change it to sprite, 2D, and UI. By the way, when we change this to 2D and UI, that is also where you can see that alpha channel gets applied. When these ones that are default, you can see they're black. They don't have that transparency. The 2D ones do. So take one we put as 2D and drag it in here. So this is an older one. This is the one I just changed, and you could actually see that I can't drag this one in. It gives me a no, and that is because the sprite mode is currently set to multiple, which was what we want for sprite sheets. But when it's just a single sprite, we need to change that sprite mode to single, apply it, and then we can drag it in there. So I do apologize for that. They look the same, but it starts as multiple. We want to change that to single, and then we'll be allowed to drag it in. Okay, so let's start thinking about what we kind of want, right? So if I go to game, I could see my screen here. One kind of issue immediately is this background does not take up enough of the screen space, so that's something we got to deal with. And the way I want my dodge game to work is the mouse is going to move the character. You guys are more than welcome to use the keyboard if you would like. We've already kind of learned how to do keyboard input. It's very similar logic for this, so I'm not going to go over that. I'm going to go teach you guys how to use the mouse in this case to move our character. So let's start off dealing with the background first. The background clearly, it's just in the center. I needed to scale through the whole screen. I could, for example, come to the scale, see what Y scale kind of fits. It looks like 2, and then do 2 on the X as well. Put it in the corner, and then kind of paste it and, move it so it looks about right. I think we need to move it 1.5. Right, so it kind of doesn't have a gap. Do that again. To where it kind of looks correct. Now there's still this green line for some reason, but a bigger issue with this is that if my game screen size changes, you could see that the background doesn't suit to match. So even though in the scene mode I am lining it up to match my camera, this rectangle here actually depends on the screen size. You can see if I make it really tiny and go back to scene, let me just pull scene over here, you can see that this rectangle is changing size. So as I change this, we can see that the camera rectangle is changing size. So we can't just tile it kind of in the scene view and expect it to work. There's two kind of, and there's going to be a lot of different ways to deal with this. Every 2D game deals with this issue some way or the other. Some games might not let you change the screen size at all. They're a fixed screen size. Some may let you change the screen size. They scale everything with it. Some may tile everything with it. So, for example, if I wanted a tiling screen where, based on the screen size, it kept adding new ones, we would have to write a script that does that, right? That can tell when the game starts what is the screen size and tile everything to it. For this, I'm going to pick the simpler and slightly more ugly solution, which is just to scale the game object. So, based on the screen size, I'm just going to scale it. So it's going to look stretched, but I think that's fine for this kind of game. So I'm going to reset everything back to kind of the zeros and ones that they were. And I'm going to make a script just to begin to scale that background. Instead of just putting my script in the root folder, I'm going to organize it this time. I'll make a new folder called scripts. And in here, I'm going to make a new mono behavior script, and I will call it BG scaler, as in background scaler. And once the script editor opens up, let's begin working on it. So what I really want to do is when we start the game, I want to get the size of this camera. I want to get like its, extents. I want to see how far left or what the width is, and then scale the width and the height based on that. Let's go back to the script. The other thing I also need to know is the size of this texture, right? This sprite, or so I should say. It takes up a certain amount of pixels, width and height. We're going to need that when we set the scale. So the width and the height information for the sprite, they're contained in the sprite renderer, so we need a reference to the sprite renderer. So the first thing I'm going to do, and I only need to run this function once, so I'm just going to make the variables all in start. Just do everything in start. I need to make a variable that's of type sprite renderer. I'll call it SR just for sprite renderer, and it's going to be equal to get component sprite render. Now I need the height and the width of the camera, right? So let's make a float and I'll call it cam height. Nice thing is we have very convenient access to this through a class called camera. Camera has a variable in it called main. This is the main camera of the scene. And then we can get its orthographic size. And we'll multiply it by 2. The reason we multiply it by 2, by the way, is that starting from the center, going up, that's the height. We also want, going from the center to the bottom. So we want this whole thing. And so we multiply it by 2. Next, we have the cam width. And that is going to be the cam height multiplied by the camera's aspect ratio. And the reason we do this is we get the camera height through this orthographic size, which is the camera's half size. That's what it says. That's why we multiply it by 2. But we get the cam height, and then we multiply it by the aspect ratio. So, for example, if the aspect ratio is 0.5, what that's saying is for every 1 unit on the height, we have half a unit on the width. And a ratio of half, by the way, would mean that we have a taller screen that is wider. Normally, our aspect ratios are more like 1.5 or something bigger, where our screens are wider than they are taller, right? But by multiplying the cam height with the aspect ratio, we can get the width. And then we want to get the sprite size. So vector 2, I'll make a sprite size. Instead of it being a vector 3, the sprite size of vector 2, because there's no z, there's no thickness to a sprite. It's just x and y. It's just width and height. And this is going to be equal to the sprite renderer dot sprite dot bounds dot scale. Oh, I'm sorry, not scale, it's size, right? Okay. And finally, we just need to set the scale of the background. So we can do transform dot local scale is equal to the new vector 3, and this vector 3 is going to be the x, the y, and the z. I'm just going to hit enter so we do them all in different lines. The x is going to be the width divided by the sprite size. The height is going to be the height divided by the sprite size dot y. And then finally the z is just going to be 1 because, there is no z scaling really. And we save that. We don't need any of this stuff here. Let's go back to our game. Attach our BG scaler. Just do it throughout component, BG scaler. I accidentally attached it to the player, so let's actually remove it from the player. And while I'm here, I'm also going to rename this to player. And we're going to attach it to the background. So add component, BG scaler. Hit play. And now it kind of stretches to match the screen. I think I just realized this green line here is probably from the next sprite sheet component. I didn't quite get it correctly. Either way, it now stretches to match. One kind of issue here is that if I was to dynamically size the screen, it's not going to update to match because we do this once in start. I'll let you guys figure out how you can solve that. Super easy. But I think this is more than enough for us where, depending on the game size in the beginning, the background scales to match. So it's always covering up the game. Next, we need to deal with the characters. So right now I have the character here. And you'll see that sometimes the character goes behind the background. And I don't want that. So what's happening really is if I go back to 2D mode, it's just that their Z is on the exact same plane, you know? So really, because our camera is looking at it from this angle, the lower the Z, you can see as I move towards the camera, Z is going to negatives. The lower the Z, the closer we are to the camera. So we can kind of use this to give ourselves some layers, right? So we can have things go in front of each other, behind each other. All I'm going to do is set the player's Z to -1. And I'll reset their position to 0, 0. Now, if I look at it, player's perfectly on top of the environment. Next, let's make a script for the player. I'm going to make a new script here. And I will call it, my instinct tells me I want to call it 2D player controller, but there is a reason we can't do that. And that is because when we make a file in Unity, a monobehavior script, it ends up naming the class that exact thing. So I call this file bgscaler, and it says public class bgscaler. So when we make it in Unity, it just matches those two. And it's also convenient, you know, just in any project, have the file name and the class be the same. You cannot start a class with a number, so I cannot call it 2D player controller. Instead, I'm going to call it player controller 2D. So just a small note, if you start off with 2, you're going to get all kinds of errors. So never start a class name with a number. In fact, you can't even start a variable name with a number. Let's open it up. And then we really want to do two things here. We want to get the, well, really we just want to do one thing to start. And that's what we're going to do in this video. And that's just get the mouse controls working. So very similar to how we did the keyboard, we need to get the mouse input first. And just like with the keyboard, how we did keyboard.current, we can start off by making a vector to every update. I will call it mouse position. And we do the exact same thing. We get the mouse class dot current dot position, and then here we need to call a function called read value on it, which is going to give us a vector2 of what the mouse position is. This mouse position is going to be in something we call screen space. So there's two kind of parts to these game engines when we think about it. There is a screen space that is a 2D space, and then there's a world space. That is what we see in this scene here, this 3D. This is a world, right? But it doesn't matter what angle I'm looking at my world in. This rectangular box here, this 2D screen that I'm looking at it on, never changes, right? So this 2D kind of thing that we're looking at is called screen space. What's behind that, what's inside that is called world space. When I get my mouse, it tells me the mouse position in screen space. I need to convert this to world space. World space is a vector 3, screen space is a vector 2. So I will make a new vector 3, call it mouse world position, and luckily Unity has a function. So from the camera, if we get the main camera, it's called screen to world point, and it takes a position, which in this case is going to be the mouse position. Let's delete all that. There you go. Next, we just kind of need to set the transform of our player. So I can do transform dot position is equal to a new vector 3. So I just want the X to change, right? If I go back here, go into 2D, click on this. I don't want the Y to change, right? Because we're not moving up and down, we're just moving left and right. So I just need the X to change. So whatever the Y and the Z are, they can stay the exact same. So we'll deal with the X after, so I'll just put 0 for now. But the Y is going to be whatever our transform.position.y is, and our Z is going to be whatever our transform.position.z is, right? The Y is going to be equal to the mouse world position.x. And we can go back and test it. Don't forget to, in our player, add the player controller 2D. And then I'll just set them to be on the ground. And there you go. Now when I move my mouse, it doesn't matter how high my mouse is, but the character moves. Now, if I was to change the screen width or start with a different screen width, this can potentially break. But because we have figured out how to do the scaling on the background, I'm not too worried about this. But if you guys want to solve that, that's another problem. That we can kind of use these same steps to kind of build a solution around. Is how can I always make sure that they are in the same spot regardless of the screen size? But there's a bigger issue we have here, and to view that, I'm just going to separate the scene. So we're looking at the scene separate from the game, and that is right now my character follows the mouse. But if my mouse goes out of the screen, we can see on the scene view it's still kind of following my mouse, right? So imagine our players playing on a windowed screen. They move their mouse all the way out of the screen. Our bullets are all spawning. They're just dodging them. There's no gameplay to be had here. So we need to somehow bind this character so they don't go past the screen area. The easiest way to do that is to clamp this variable. So whatever mouse world poses, whatever the x is, we say, hey, it cannot go below this value. It cannot go above this value. So we could, right after we convert the thing, we could say world mouse position or mouse world position is equal to, there's a library called mathf. This contains a bunch of math functions. One of those functions is clamp. Clamp takes a value, a minimum, and a maximum, and it makes sure that value never goes below the minimum and never goes above the maximum. It clamps it. So the value that we want to clamp is the mouse world position. For now, I'll just say -8 and 8 are going to be the values I want to clamp it to. And it's mouse world position .x, and really I want to be setting the mouse world position .x because I don't really care about the y. Now when I hit play, I can see that I can move it, and it's clamped, right? Awesome. We can just make this a little bit better. Rather than clamping it between an arbitrary 8 and -8, let's clamp it to the actual camera. So to start, just like in the BG scaler, how I got the camera width and height, I'm going to do that on start. But I need to be able to access this variable from our update. So really we need to make this variable right under our class so everyone can access it, right? So I'll make a float half height, and I'll make a float half width. So half height is going to be equal to the camera.main.orthographic size. You'll see here I don't multiply it by that 2. That's because I'm also calling it half height. I only need half of it. And same thing, the half width is going to be the half height multiplied by the camera's aspect ratio. So camera.main.aspect. So this gives us half our width from the center of the camera, half to the right and half to the left. And really, we just need to, instead of setting, and I can move this around so we have more space, instead of setting this to an arbitrary -8 and 8, we want to set the negative to be the camera's x position. So the camera.main minus the half width. And we want to set the other half to be the exact same thing. The camera main transform dot position dot x plus the half width. So again, really what we're doing here is we're getting the center of the camera. That's the camera's transform x. We're saying we don't want it to go anywhere from there to minus the half width. So half to the right. I'm sorry, half to the left. And then we don't want it to go beyond where the camera starts plus half to the right. So you could just use the minus half width and plus half width on its own. But the reason we don't do that is in case we move our camera around, right? Like right now, if I click it, my camera's at 0. But if my camera starts moving around, those values don't make sense. Simply by just adding the camera position to it, we can kind of make it relative rather than an absolute value. And that should clamp it to the screen. Again, let's pull out the scene here. Let's zoom out. And you can see if I move past the screen, my character is stuck there. Now, maybe you don't want them to be stuck at the exact edge of the screen, so you could add, a number to it just to kind of like make it, to give it a little bit of extra padding. And before we try it, I think I got these numbers, these signs mixed up, and 50 might be too much, so let's just do 2. And there you go. Now it's clamped with some padding, and depending, I could change the screen size, hit play. And it's still going to be nice and padded. Okay, awesome. So that was it for this video. That's like the very basics of setting this up. We got the, the 2D dodge controller working. Next time we will add some spawning obstacles for us to dodge and also add some sound effects and stuff. One quick thing with this is before, we leave this video here, I need to add a collider to this. I'm just going to do that right now. 2D objects have their own colliders. So if I clicked here and I started searching collision, you can see there's a box collider 2D, capsule collider 2D. So 2D has their own collisions. The reason being that 2D collision calculations are way simpler. So these are much more optimized than using, a 3D shape. Specifically, we have something called a polygon collider. And if I add that, zoom in, you can see I get a nice little collision that's the exact shape. So this is just going to make our game feel a little nicer than instead of using a box collider. If it doesn't give you a proper shape, you could even come into the polygon collider where it says edit collider, and we can start moving these vertices around. But this shape is good, and this is going to just set us up for next time when we start working. Anyway, thank you for watching.